Hello students, today we are going to see an interesting and important topic, that is D and F block elements. Directly we can go to most important question because this topic is full and full informative topic only. So directly we can go whichever relevant for the board. Let us go for it. Okay, what are the things you can expect from this topic means identification of compounds and elements. Complete the equation. They will give that equation half. You have to complete that equation. Redox reaction. Okay. Now, next one, give reason question. 100% you will get give reason question. So you have to concentrate in that part only, I'm telling. Next one, properties of the elements. What are the properties of the elements? Lanthanides, actinides. What are the properties of the elements? They will give certain elements and you have to give the properties of that, and lanthanoids, actinoids, contraction and whatever similarities, whatever difference. So those ideas, those questions you can expect from this topic. Okay, now first and foremost, let us go on identify that electronic configuration of these ions, right? Okay, Cr3 plus ion, Mn2 plus ion, Fe2 plus ion, and CO2 plus ion. Okay, generally this kind of question, objective type question only, they will ask four option in that one amount. See, this is a ion. Now atomic number they will provide, but atomic number you just think it over there. This is chromium 3 plus, so that means outermost orbital 3 minus. In that way you have to select according to that four option. Yes, come on. Before going for it, I will give that order: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these are the 10 first line elements. So if you know orderly, you know the atomic number. Okay, now again I will tell you: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, 21 to 30. Now, in that, which one it is? Chromium 3 plus. First and foremost, let us consider that atomic number of chromium. Atomic number of chromium, it is 24. How can you say it's a 24 easily? That's what scandium, titanium, vanadium, chromium, manganese. 21, 22, 23, 24, 25. In that way. Okay, so before going for the ion, let us go for the atomic number wise. Okay, now chromium, its atomic number 24. So how can you write that electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But is this correct? No. Why? Because half filled and completely filled are more stable. So what happened? The one electron which is giving here, so automatically that 4 becomes 5, this 1, this 2 become 1. So naturally it is completely or half filled. So half filled and completely filled are more stable. That already you have learnt in grade 11 only. I hope you remember. Now come to this point. Now they are asking that question: Cr3 plus ion. So that means what it is? 3 electrons from the outermost orbital you have to release. So that means minus 3 electrons. So how will you write it? So I just have taken that argon. You know why I have taken that argon? Argon, it is completely filled. 18 electrons are there because it's a noble gas element. So naturally, it's completely 18 electrons in its hand. So we can take argon. Argon, it is 18, no? So from here to here, 18. Now remaining what it is? 4s1, 3d5. In that, you have to release what it is? 3 electrons. So that means here 1 and here 2. So how many? 3d3. Is that correct? This is the way. So generally they will give the option 3D argon 3D3. or they will give something else, A, B, C, D, or else atomic number. How many atomic number here? 18, 19, 20, 21. In that way, they will ask. Okay, hope you're clear with that. So 21, 22, 23, 24, like that. Some people, what they will think, 24 atomic number, so they will consider 24. No, you have to release 3 electrons from that. So in that way also you can consider electronic configuration also you have to consider. So both at a time, I just bring it to you. You can directly go for this. Why I'm bringing this point, half filled and completely filled, I just wanted to mention. I just bring it to your kind notice. Hope you're clear with it. Okay, now Mn2 plus. Mn2 plus. So before going for Mn2 plus, directly we can go for atomic number. Atomic number, this is 24 means this is 25. Z, 25. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Then you can ask, is there any combination? It's half filled and it's completely filled, so no problem. We no need to disturb. Where you have to disturb, chromium and yes, one more element from that first row. What it is? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. In that copper also you have to take that copper and chromium are special. Why? Because completely filled and half filled. That category wise, these both element are very famous. Right? Okay, there we have to little disturb that element to bring that half filled and completely filled. Remember that. Okay, now this is what it is, electronic configuration. Now, how to write Mn2 plus? Here, Cr3 plus, because you have to write it in this way. So, Mn2 plus. See, this is Mn, only element. Now, this is Mn2 plus ion. So, how can you bring it here? Argon, the same way. Argon 3d5. I have written 3d5. Is it correct? Yes. Check the answer whether it is correct or not. And suppose if they are giving atomic number like this, Mn2 plus, how many electrons will be available? 23 or 25? Which one you will take the answer? Put your answer in my comment section box. Hope you're clear with these two things. Other two, you just pause the video and check the answer. Okay, this is, I will tell this. Fe 26 and cobalt 26. Next to what it is? 27. Come on. Try. Pause the video and check the answer. Fe. What is the atomic number? 26. And 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, now Fe2 plus ion. So how will you write it here? Ar. So 3d6. This is that. From the outermost orbital, you have to lose 2 electrons. I hope you got it. The next one, CO2 plus. So just first and foremost, we'll go for that element, then we can go for that ion. CO, what is that? Atomic number 27. So here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Now here CO 2 plus. 2 plus only now. Yeah. Now how will you write it the same? Ar 2 electrons from the outermost orbital. You have to release 2 electrons. So you will get 3d7. I hope you got this answer. Electronic configuration like this they may give, or else one more thing, atomic number minus this 2 plus ions. In that way they will give. Hope you got a clear idea. Now one more question. Which is more stable, Cu1 plus ion or Cu2 plus ion? In that way they will ask the question. Copper atomic number, it's 29, right? Atomic number set. So how can you write it? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Okay, now we have to disturb the electronic configuration. Why? Because half filled and completely filled more stable, right? So in that one electron which is going to give here, so automatically here you will get 1 and here you will get 10. Now this is the electronic configuration of copper. Now I'm coming to that point of Cu plus 1 ion, Cu2 plus ion. Which is more stable? Cu plus. This is 1 Ar, we can take it. Ar, 18 electrons are completed. Here 3d10. Whereas Cu2 plus. Here Ar. What is that answer here? 3d9. Now, in this, which is more stable? According to that electronic configuration, Cu plus ion, it is stable. According to the electronic configuration, this might be stable because it is completely filled. Whereas, according to this, which is more stable comparatively, these two means this only will be more stable. Why? Why? Because nuclear charge of copper. That is the reason Cu2 plus is more stable than Cu plus ion. Hope you're clear with that. Okay, now next point, assertion reason question. Now, first point what we mentioned, electronic configuration, objective type questions. It will be easy only for you. Electronic configuration, ions and all easily you can recognize. Assertion reason question and give reason questions. Come on, both together, let us watch. Okay. Now, first question, why silver atom has completely filled d orbitals for d10 in its ground state? How can you say it's a transition elements? Completely filled d orbitals means that is not a transition elements. I hope you got an idea. Okay, now this Ag, what is the atomic number of Ag, argentinum silver? It is 47, right? How can you write electronic configuration? Kr, because 47 so big, so directly we can go for that shortcut. Kr 4d10 5s1. So they are asking 4d10, it is completely filled. That means how can you say it's a transition elements? Because transition elements means d1 to d9 only. But here d10, how can you say? Yeah, what it is there in the electronic configuration D10, whereas it's in the compound, actually it's a +2 oxidation state. +2 oxidation state. Example, AgO, Ag, F2. So these are all electronic configuration. If you go for it means you will get what it is 4d9 only. Why? Because +2 oxidation state, outermost orbital 2 electrons are releasing. So naturally 4d9 only, it's there in that inside the border, not outside. It is not exactly 4d10, it is 4d9. So that means it is inside the, so naturally it is a transition element only. So this is the way you have to answer. 2 more question or 1 more question. So first and foremost you have to prove this and you will get that idea through this example. Hope you're clear with it. Okay, we'll go to some other question. Next, one more important question, most expected question also. Explain why zinc, cadmium, mercury not regarded as transition elements. Even they asked CBSE paper in 2020 also they asked, and actually it's very important. Another question, scandium is transition metals, whereas calcium is not transition metal. Why? It's so simple. Atomic number, this is 20 and this is 21. So this is completely, it's there inside that d, before the d orbital only. This D orbital, it touches because it's 21, atomic number 21. Okay, now let us go and watch that first one. Why zinc, cadmium, mercury? It's not regarded as transition metal, though it has touched D10. Yes, actually, zinc, atomic number 30, and cadmium, atomic number 48, and mercury, atomic number 80. Actually, all these are all completely filled D10, completely filled orbitals of D10. Generally, what is transitional elements? It is D orbital, it has to be incomplete. Then only we can accept as a D transitional elements. So D1 to D9, we say it's a transitional elements. Once it has touched D10, it is not a transitional elements. In that way, zinc up to that mark, completely filled D10. It's D10 orbital. The same way this also, cadmium and what it is, mercury also. So we cannot accept as a transitional elements though it is present in that group. Okay, hope you're clear with it. Okay, now next one. Scandium and calcium. Scandium atomic number 21. So, atomic number 21. So, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. It touches d orbital and it is having one electron. Whereas calcium, atomic number 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. It does not go for that. It's 20. It doesn't touch the d orbital. So naturally it does not have that property of transitional element. Here, one more point I wanted to mention, whether it is there in the ground state or in the oxidation state, d orbital, it has to be incomplete. Then only that is belongs to transitional elements. Here, you see Zn2 plus, Cd2 plus, and Hg2 plus. This also, electronic configuration, if you are writing, it is completely filled only. Now, if you go for this Ar 3d10. Okay, 4 is to anyway it has gone those electron. So 3d10 it is completely filled. Whereas if you are going for this electronic configuration, this also the same. 2 electrons will be out means that will be filled, completely filled. D orbital transitional elements means it has to be incomplete, D1 to D9. See, suppose if you are out, marks are out means you are outstanding students, you are not belongs to that class, you are in the topper class. Okay, so in that way you please remember. Hope you are clear with that. Okay, we'll go for some other question. Now next, one more important question, very interesting also. Which of the 3D series of the transitional elements exhibit large number of oxidation state and why? See here, manganese. Manganese is having highest oxidation state. So atomic number it is 25. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Okay, outermost orbital. So here, how many electrons are there in the outermost orbital? 7. So that means Ar 3d5, 4s2. So maximum number of electrons ready to lose or ready to share. So in that way, plus 2, it starts from plus 2 oxidation state to plus 7 oxidation. So maximum number of oxidation state which is available in that manganese. And one more thing, it can take part in the bond formation fully ionic only. Right? Hope you're clear with it. And here plus 2 to plus 7, that means plus 2, plus 3, plus 4, plus 5, plus 6 and plus 7. Hope you're clear with it. And everything it will be ionic bond formation. oxidation only. Hope you're clear with this question. The next one more important question. Why is the highest oxidation state of a metal exhibits in its oxide and fluoride only? Very simple and very easy also. You know, fluoride and oxide are very strong oxidizing agent. Next, one more point here. Due to that high electronegativity, high standard reduction potential. These are the three main points you have to note out. First one, what it is? Here, fluorides and oxides are very strong oxidizing agents. Strong oxidizing agents, and due to that, second point, what it is? Due to that high electronegativity, high electronegativity, electronegativity, and high standard reduction potential. So these are the reason for that. That will be what it is. Highest oxidation state of a metal exhibits oxides and fluorides only, because one thing, it is a strong oxidizing agent, and due to that high electronegativity and high standard reduction potential. Hope you're clear with these questions. Okay, one more question. Next, one more important question. Which is the stronger reducing agent, Cr2 plus or Fe2 plus? Generally, Cr2 plus is very strong reducing agent. Why? Because it oxidizes very easily and it will form Cr3 plus ion. Whereas Fe2 plus, it cannot oxidizes very easily to become a Fe3 plus ion. Come on, let us go for the electronic configuration. Cr2 plus, electronic configuration Ar 3D4. So it is a strong reducing agent. So it is oxidizes to what it is, Cr3 plus. So 3 plus means electronic configuration. This is what it is, D3, right? So it will take that T2G3 electronic configuration half filled. Whereas here Fe2 plus, the same way Ar 3D, here what it is, 6. So it cannot oxidizes very easily to become what it is, Fe3 plus ion. That is the reason this is oxidizes very easily, whereas it does not oxidizes very easily. So that is the reason this is very strong reducing agent. And one more point, based on the number of electrons given out, chromium, it is actually what it is, plus 6. So 4 electrons it can given out, whereas here Fe2 plus, only 1 electron can give out. So in that way, here 4 electrons can give out and here only 1 electron. That so it is not oxidizes so easily, whereas here it is oxidizes so easily. That is why we are telling it is a strong reducing agent. Hope you're clear with these points. Okay. In our next session, I would like to give some more important questions also. And thanks for watching. Please subscribe this channel and hit the bell icon so that you will get all the notification. Thanks for watching.